Okay? So, let's go through an example. And before you, because I haven't posted the 8B yet, because partly I wanted to see how far we got today, especially if you're looking at the text. The homework is going to be very, the question I'm going to ask are very conceptual. I'm not asking, you're not going to be doing calculations and stuff based on this. It's more just, what I really want, I think the important thing, the important fundamental thing to walk away after one lecture on HLM is kind of understanding this notion of these multiple levels. What's the relationship between, what's level 1, what's level 2, what's in this sort of a model, and what are the different sorts of questions that you're asking about? Because that's where it comes into play in education. That in education we're often dealing with situations that I've got, I want to look at, do certain interventions, does an intervention work? And I can't give an intervention just to random kids at a school, as I'm trying a new math curriculum. So maybe it'd be great if I could somehow randomize all the kids and every kid's getting different math curriculum. But then you're going to be, each teacher's going to be teaching 4 different ways in the same classroom. That's not practical. So you have problems that, okay, I want to look at the curriculum that this teacher's using relative to the curriculum that teacher's using. So you end up with these situations where you've got characteristics at one level, like we saw already, or maybe the school. We're a one-to-one laptop school. How does that affect kids' scores? We're not a one-to-one laptop school. How does that affect kids' scores? And you could even look at, well, I'm a one-to-one laptop school. How does this affect free and reduced lunch kids? How does this help my higher risk kids with their math scores? So it's a characteristic at level 3 influencing the effect that a characteristic at level 2 has on that outcome at level 1. Woo. We'll kind of walk through this. But again, as we start to look at this, I don't want you to start to think, oh my God, he's going to have me doing all. We're just going to keep it conceptual at this point. There's a whole course on HLM. So the kind of the example I want to use, kind of working off of where we just left off, is is a question: does providing laptops to every student at a school increase students' math skills? And to do this, we're going to work with 25 schools. And to kind of keep the numbers simple, we're going to have 500 total students across those 25 schools, 20 kids per school. So we may be working with like a very specific pre-algebra, what's an 8th grade math? Well, some 8th grade, kind of an average 8th grade math classroom. So we got 25 schools. Within each school we got 20 kids, and each student is assessed 6 times. So you can kind of see right there, kind of the nature of this nesting. What's my N? What's my sample size? Is it the 25 schools? Is it the 500 kids? Or is it the 3,000 different assessments? Well, it kind of depends on the nature of the question and the nature of the data. So the one way people historically have often answered this, way back, and education was late to catch on to this. What's really kind of funny, some of the big names for HLM are out of education, and psychology ran with this approach. Business ran with these approaches. Education fought tooth and nail against it. It's kind of interesting. But I digress. Again, we don't need to know, we don't need equal ends. I'm making the numbers, I'm kind of assuming everything's equal, but when I say 6 assessments per student, some kids could only have 3, some kids could have 8. That's okay. We can work with that. Same with the number of kids per school. And we want to look at this impact of that school level variable. Does the school give every kid a laptop? On the child, ultimately on how did the kids do? Oh, and as I was saying, how you'd often have seen this in the past is people would say, okay, my unit of analysis are schools. So I'm just going to take the average for schools on all their kids. And I'll do, my N will be 25, and I'll look at these school averages for the schools that have 1-to-1, and the averages for the schools that don't have 1-to-1, and I may have 12 over here and 13 over there, and I'm just going to kind of treat it that schools are my level of analysis. There's all sorts of problems with that, but we don't have time to go there. Well, other than to say you do that, you can actually draw the exact opposite conclusion you should draw. And there's some awesome cases where that happened, much to some people's embarrassment. When people came back and looked at the data more closely, actually I'm going to go, well, we got a little time. Well, if we have time at the end, I'll give you a couple of them. So you don't want to do that. This is the way to do it. Okay, so what's the impact of that school level variable? Do all the kids get a laptop? Kind of a natural question. We want to kind of obviously look at, do those outcomes change over time for the kids, and what might be related to are those outcomes, are that math performance, those math skills changing over time. So we're back to the gamma, beta, pi, oh my. And we'll start with we start with our level 1 model. And actually, we can call this right here as our level 1 model. And now notice there's lots of subscript. And that's just to keep track of the nesting and the level that you're on. So we have y sub Tij. And the Tij is just a way of saying it's the y, it's the score, the assessment at time t for kid I at school J. Because remember, later on we're going to talk about, well, what's the school average? Or what's the child's intercept? What's the child's slope? So sometimes we're going to have a t. In this case, at level 1, we're talking about, because we're predicting every time point. We're predicting all of those assessments. But other times, we're not going to be looking at that anymore. So it'll be kind of interesting to keep track of what happens to all those subscripts. But for now, it's Tij is just a way of saying it's the outcome. It's the score for child. It's a score at time t, 1, 2, 3, 4, 5, 6, for child I, which can go 1 to 20, right? There's 20 kids in each school. At school J, which is 1 to 25, because we have 25 different schools. And that's based on a model that is pi 0ij. Now remember, pi is just, think of it as regression coefficient. Because we've got 3 levels, we're going to have 3 levels of regression, with 3 different types of regression coefficients. So at level 1, for this type of model, where we've got where we've kind of got kids assessed multiple times, the standard notation is pi 0 is pi's for the regression coefficients, but they're just like b's. And notice we have a b0, that's the intercept. And remember, we said when we were doing this, every child's going to get their very own intercept, and every child's going to get their very own slope. Merry Christmas. I could do something with that. It's Christmas, you're opening up presents. Oh, look, Mom, I got a brand new intercept. Oh well. So pi 0 ij is just a way of saying what's b0? It's the intercept. Pi 0 is the intercept for child I at school j. This is just a way of mathematically writing what we just talked about. Every kid gets their own intercept. Pi 0 intercept for child I at school j. Pi 1 ij is the slope. Right, beta 1 is your slope. You know, that's the effect. That's the slope of our regression line. Ij is, so it's just the slope, just like B1, for student I at school j. Times time, that's because we're looking at, that's our predictor in this case. Time 1, you know, what that's, look back at the graph. Our x is time. Are you time 0, time 1, time 2, time 3, time 4, time 5? So it's whatever their slope is, just like, again, whatever their regression coefficient is, times time Tij, that's which time is it for that student, time 1, time 2, time 3, for student I at school j. Plus ETIJ, that's just the error term at the end. Right? We saw in the regression, when we did that at level 1, we had the regression line, and you notice some were above and below. Oh, they were getting tutored, so they were above the regression line. They weren't getting tutored, they were below the regression line. There was those errors. This is just the error for a time t for student I at school j. So that's just their individual error. How far they were above or below the regression. How far that specific student was above or below their regression line at that specific point in time. So kind of the simplest model based on this is just, well, do children's math skills increase over time? And we'll actually take a break in just a second. We can kind of see that's right here. If their math skills, do their math skills increase over time? If it does, then we would expect pi 1 ij to have some positive, significant positive value, right? Here's time. Is the slope, overall slope, positive? Notice we're not talking about what type of school. We're not talking about what type of kid. This is just looking at, do the scores increase over time? Now notice, though, there's a whole bunch of pi 1 ij's, because every kid at every school has got their own. But here's kind of where we're testing, kind of just that, you can think of, we're looking at that time effect in the very simplest way, just time all on its own. Right? It's that slope. Here's our predictor. So you can think of time as 0, time 1, time 2, time 3, time 4. Right. Kind of remember again, with our level 1 model, our outcome is YTIJ, which is the score at time t for child I at school j. So that's 3,000 math tests is what we're predicting. This is where we're predicting each of the kids' math tests based on their data. Pi 0 ij, there's 500 different intercepts. Those are that, remember that's that, the pi 0 ij is the intercept for child I at school j. And we have 500 kids, so there's 500 pi 0 ij's, 500 intercepts for the 20 students at each of those 25 schools. And you can think about it like, in a way, here is if we actually wrote it all out. Here's the, you can think of, here's the regression equation for student 1. Here's the regression equation for student 2. all the way down to student 500. We have 500 regression equations. We don't see them, but conceptually you can think of them as being there. Each kid has its own regression equation where we're predicting their score at time t for student 500. My score, over the six assessments. Their score for student 2. And you can notice the regression equations, there's a lot of variability. Here's the intercept's only 0.4, here's an intercept of 12. Same with the slope. Here's a slope of 1.3, here's a slope of 5.6. So there's a lot of variability in the intercepts and a lot of variability in the slopes. And now, kind of our next step is we want to understand that variability. I want to understand why is this kid's intercept so much higher than this kid? Why is this kid's slope so much higher than that kid's slope? That's going to become our focus. And this is, as I kind of started off earlier, and then we'll take a break. This is the real power of this sort of modeling. What is slope? Slope is growth. We talk a lot about, kids' growth. We want to help kids, gain. We want to help kids grow with their reading skills or grow in their math skills. What is a slope? The slope, and that's what we're measuring, 5.6 is the slope. The slope is growth. Before this, I remember when I first started teaching this course many years ago, we didn't go here at all. There was techniques called residualized change that you would do. And you're saying, well, based on your pre-test, here's what I predict your post-test is, and we'll look at the residual to see are you above or below. And we would talk about that as being change or growth or gain. But it's not. It's kind of what's your residual? It's not. It's a poor substitute for growth. This is growth. I don't even go there anymore. I mean, notice we didn't even talk about residualized change. You don't see it in the books anymore. There was kind of a transition where people still talk about it. You don't really see it that much. I mean, it still has use, but you want to understand growth, this is how you do it, because this is growth, and that's what we're going to now focus on. Okay, let's take a break, and we'll come back in.